we officially in lesson 3.5 today are talking about zeros of polynomial functions. Now, zeros is a vocab word that should be somewhere in your brain, maybe, hopefully. Do you remember anything about zeros?
Yeah.
What do you remember?
Yikes. Isn't it zeros like they're replacement of y?
How'd you say it?
Is zero like the replacement of y?
Okay, and so if you put 0 in for y, then what do we end up finding? X-intercepts, yes? Okay, so when we talk about zeros, zeros are another name for x-intercepts, and it happens when we put 0 in for y. Okay, so the definition up here is zero of a function is an x-intercept of the graph of the function. We also talk about zeros being solutions of a function. So when we talk about x-intercepts, we're also talking about solutions. Now, as we look at A, they're asking us two questions. One, they're asking us what are the zeros? And so that's them saying what are the x-intercepts? And then the other piece is to graph this function. And this is, the graphs we're doing today are not with the aid of Desmos or a calculator or anything like that. It's graphing based on what we know. We're not going to have specific graphs, but we're going to have a general graph. So, as we look at the first question, asking what are the zeros? Well, remember officially to find your zeros. It was just mentioned that in order to find the zeros, you're putting in 0 for y, so you can find your x's. So in this case, that means we would have the equation, I'm going to flip it, x times x minus 4 times x plus 3 equals 0, because f of x is another name for 0. Well, this is already in factored form, which makes it nice. How do we solve this?
Would we use FOIL?
No, I don't want to FOIL.
You tried.
Yeah. Set each factor equal to 0. Because what we have here is we have 3 factors multiplying to equal 0. If you have multiple things multiplying to equal 0, at least one of them has to be 0. So we're going to set each factor, including this x, so anything that has an x. So we're going to set x equal to 0, x minus 4 equals 0, and x plus 3 equals 0. Now, you guys know the obvious. X equals 0, that's already an answer, right? If x minus 4 equals a 0, we're going to add 4, and x equals 4 is an answer. And if it's x plus 3, we're going to subtract 3, and x equals negative 3. Okay? So right there, when they asked what are these zeros, that's what we're looking at right there. My zeros are 0, 4, and negative 3. Okay? The other piece we're being asked is to graph the function. Now, I'm going to come back to the middle for a moment. If I sketch a graph right now, okay, what do I know about my graph right now? Based on the fact that I just found these 3 zeros, what do I know about my graph? Okay, it's going to intersect the x-axis 3 times, specifically at
-3, 0, 4.
-3, 0, and 4. Now, do me a favor when you set up a graph. Okay, and this is just a basic sketch, but if you ever have to sketch a graph, do put some kind of numbers on there. I put the numbers of interest on there, but give me something so I at least know, is this graph counting by 1s? Is it counting by 2s? How is it counting? Okay, now, without knowing anything else, I know my graph is going to cross through the 0, the 4, and the negative 3. What we've got to figure out is, okay, what's it doing in the interim? Okay, what's it doing in each of these blank spaces? Okay, is it above? Is it below? So, with that in mind, we're going to use a skill that we talked about earlier this year, and that is we're going to set up a number line, and we're going to try and figure out what's going on in each of these intervals. Okay, so on this number line, I'm going to put the 3 zeros. They need to be in order, but they don't have to be specifically spaced according to how far apart they are. Okay, they just need to make sure they're in order. And I want to know what's going on in each interval. To the left of -3, is this interval negative or positive? Between -3 and 0, is this interval negative or positive? Between 0 and 4, is it negative or positive? And between 4 to the right, is it 0 or positive? Or positive or negative? Okay. Now, with that in mind, do you guys remember doing something like this earlier? What's a value we can take down here and test? What's a value to the left of -3? -4. And if you don't like -4, -5, -10, -12, anything to the left of -3. Now, the question becomes, what are we going to test it in? And this is where I'm always going to say, you're going to want to test it in your factored form. So we're going to test it in this case, my factored form is x times x minus 4 times x plus 3. And on this first one, it was suggested that we use -4. Now, I don't need to know a numerical answer. I just need to know, is it positive or negative? So tell me, if I put -4 in for x, that's going to give me a negative factor. Okay? Again, I'm not keeping track of numbers, just signs. If I put -4 in for x, that's going to be a negative. If I put -4 in here, what do we know about -4 minus 4? That's going to produce a negative. If we put -4 in the last factor, what do we know about -4 plus 3? It's a negative also. What do we know about a negative times a negative times a negative? 3 negatives multiply to be a negative. So what we know right now is this whole interval is negative. So I know right now that my graph, when we get over here, before we get to -3, it's going to be negative, and that means it's going to be below the x-axis. Check the next interval. What value do you want to test in between -3 and 0? -1. Okay. Your basic options are -1 or 2. Whichever one makes you happier. Okay, if I put -1 in for x, that's going to result in a negative. What about -1 minus 4? That is a negative. And -1 plus 3 is a positive. Negative times positive results in a positive, right? An even number of negatives multiply to be a positive. So this interval is positive. Okay, repeat the process again. What do you want to use between 0 and 4? Okay, 1. 1, 2, or 3 are your best options. Not that you couldn't go crazy and use 1.4 or something. But, okay, if I put in 1, 1 in place of x results in a positive. 1 minus 4 is going to be a negative. And 1 plus 3 is a positive. Positive times negative times positive. That's going to be a negative, right? 2 positive times a negative is going to be a negative. So this interval is a negative. And you can maybe guess what's going to happen, but what's a number past 4 we could use? I put 5 down. Okay, any number 5 or above. If you put 5 in for x, that's a positive. Put 5 minus 4, that's a positive. And 5 plus 3 is a positive. Notice I'm not keeping track of specific numbers. 3 positives multiply to be a positive. Okay? Now, it's just about drawing your graph. Okay? Is this graph going to be specific? No. It's going to be general shape. If we know Okay, so before -3, my graph is where it is negative. So it's going to be below the x-axis. Between -3 and 0, my graph is going to be positive. That means it's going to be above the x-axis. Between 0 and 4, my graph is negative, so it's below. And then after 4, it's above. So we're going to start down here. We are negative right there. Between -3 and 0, I'm going to be positive. Between 0 and 4, I'm going to be negative. And then to the right of 4, I'm going to be positive. Okay, guys. What this gives me? It gives me the general shape of the graph. And it gives me my x-intercepts. Okay? If I graph it on here, this is x times x minus 4 times x plus 3, right? So if I graph this on here, okay, well mine kind of goes off the screen, but if you watch it, did it make that same shape? Okay. See if I change these values, if we can see the graph better. Yeah, most of it. Okay. Maybe my graph doesn't go as low or high. I'm not looking for that specific. I'm just looking for the general shape. Okay. Questions there? Okay. My notes definitely are a lot neater than first period.
Well, now you know.
I know. Well, I have my answer key here. I know what to expect. First hour, I struggled with getting everything arranged, spaced, not running out of room. Hopefully you guys did better than I did this morning. But okay, let's try a couple more of these. Let's try B, which I think, yeah, I put B on a new screen. Okay. Now, what's different about A versus B? What? There's no parentheses. A was nice to us. They'd already factored it. B, it's not factored. So we're going to set this equation equal to 0, but then the first big thing we have to do is we have to factor this. So we're going to take 4x cubed plus 4x squared minus 24x, and we're going to set equal to 0. And now we're going to dive deep into our brains for factoring skills. Now, there's a question that we should always ask ourselves first when factoring. I'll be honest, I am the first to forget. Is there a GCF, greatest common factor? Does that sound familiar? I think I guess I don't forget to ask. I ask it in my head, and I don't always ask it out loud like I should. So you should always check for a GCF. There is one here. What do all three of those terms divide by? 4 and x, yes. Do they all have at least an x to the first in common? They do. So I'm going to factor out a 4x, which means I'm going to put the 4x out front, and we're going to divide each term by 4x. 4x cubed divided by 4x becomes not 4x squared, but x squared. 4 divided by 4 is 1. And then subtract your powers. Plus, what's 4x squared divided by 4x? X, right? Subtract your powers. 4 divided by 4 is gone again. Minus, what's 24x divided by 4x?
6.
Yeah, x is canceled. 24 divided by 4 is 6. In my parentheses, equals 0. Okay, we found a GCF. Am I done factoring? No. Those parentheses should look familiar. We should know how to factor those by now. Okay, that's definitely, we've done a lot of that. You did that in Algebra 1. Now that 4x, don't lose it out front. X squared plus x minus 6 is going to break into what? 2 sets of parentheses, right? That's that typical form. I'm hoping it looks familiar to you. Okay. X squared always breaks into X times X. Okay, and then what do I need those numbers to do?
Product of -6. So 1.
Okay, yep. They have to multiply to be -6, and they have to add to be the invisible 1. Numbers that do that are, did you say 3 and -2? Okay, 3 times 2 is 6. If you're multiplying to be a negative, one of them has to be negative. If we wanted to add to be positive, larger number positive, smaller number negative. Okay, put those in your parentheses. One parenthesis is x minus 2. The other parenthesis is x plus 3. Are those also my zeros? No, those are just my factors, right? Don't stop there and say, okay, I know what my graph goes through at -2 and 3. No, those go into my factors. Now what are we going to do? Set each factor equal to 0. So 4x equals 0. X minus 2 equals 0. And x plus 3 equals 0. So we can solve those. Okay. What about 4x equals 0?
Would it be 0?
Yeah, because officially you divide by 4. And you have x equals 0. So one solution is x equals 0. If x minus 2 equals 0, we're going to add 2 and x is 2. If x plus 3 equals 0, I'm going to subtract 3 and x equals -3. Okay. We've got our 3 solutions, or our 3 zeros. Now, I want to know what my graph is going to look like. If you want, go ahead and set up, if I go ahead and set up this over here, what do we know this time? My graph has to cross the x-axis at -3, 0, and 2. Now, okay guys, let's set this up. Let's talk about testing. There's different ways we can test. I've got some shortcuts for you. So on your number line, just put them in order. -3, 0, and 2. And yes, we need to test again. Okay, there's some things I can point out, but, you know, is it possible this graph looks like the previous graph? It is. Is it possible this graph flips upside down? It is. Is it possible this graph does something else crazy? It is. Okay, there are several variations of what could go on here. And so we need to test. Now, here's my question. Where are we going to test these values at? Last time we tested them in the original, but the original was also the factored form, yes? My recommendation is you use the factored form. It'll be easier math on your brain, okay? So my full factored form is right here. And I really thought I was in a different color. My full factored form is right there. I'm going to suggest we use the factored form to test into. So I'm going to suggest we test by plugging into 4x times x minus 2 times x plus 3. That's my suggestion. Now, could you instead, if you want to, plug into the original unfactored equation? You can. That's more the calculator math. I try and do more of the, I don't want to pick up my calculator type math. So, what number do you want to test with to the left of -3?
-4.
Okay, -4 is a good one. Keep in mind, do you have to write down what you're testing with? No. That's me giving you information for your notes. So when you look back later, you can figure out what the heck you did. Now, if I put -4 in, I'm just plugging into each of my 3 factors. So, when I put -4 in, 4 times -4 is going to result in a negative. I don't care that it's -16. It's going to result in a negative. -4 minus 2 is going to result in a negative. -4 plus 3 is going to result in a negative. What's a negative times a negative times a negative? A negative, yes. 3 negatives multiplied together means this whole interval is negative. Whether you write a sign, write the word, whatever you want to do. Okay? Repeat the process, yes? What'd you use between -3 and 0? -1? -2? Okay. 4 times -1 is a negative. -1 minus 2 is a negative. What about -1 plus 3? Positive. Why did I just write?
I don't know.
Okay. So, negative times positive. Am I there? Yeesh. Negative times negative is a positive, times another positive is a positive. Okay. Well, yes, today a lot of them are going to alternate. Don't always assume that they're going to alternate. Okay. What'd you test between 0 and 2? 1. So if I put 1 in, 4 times 1 is a positive. 1 minus 2 is a negative, and 1 plus 3 is a positive. Positive times positive is a negative. You guys all of a sudden went radio silent on me. Okay. And what'd you use in last interval? Okay. Something bigger than 2. 3 is what most of us are going to pick, but whatever you want. Okay, if we plug in 3, 4 times 3 is a positive. 3 minus 2 is a positive. 3 plus 3 is a positive. 3 positives multiplying together is a positive. Okay, so ultimately, what ended up happening? This graph ended up looking the same, didn't it? Now, I'm going to draw my graph in, and I want to talk about one other connection here. So where do we start? We start where? Negative. So we're going to start down here. Between -3 and 0, we're going to have to be positive. So we're going to be up above here. Between 0 and 2, we're going to be negative, so down below somehow. And then to the right of 2, I'm going to be positive. On your quiz yesterday, you were asked about end behavior, yes? Let's go back to our lead term here. What's the highest power? This is a degree 3. What do you remember about end behavior? 3 is odd. What do you remember about odd end behavior? My end behavior is either down and up or up and down. We met that, didn't we? The lead coefficient is a positive 4. If your lead coefficient is positive, what do we know? Down and up. Did I end up down and up? I did. So that's another something that could kind of speed it up, because you know you have to start negative and end positive. And in all honesty, with this amount of zeros, you know you're going to do that. Most likely it's going to do look something like this. Okay? I will say when we get to the next lesson next week, we talk about the fact that we don't always just cross through the x-axis. Sometimes at zeros, they'll go down and touch it and go straight back up instead of crossing through it. So that's why I don't want you to get hooked into the, oh, there's 3, I know exactly what it's going to look like. Okay? Okay. One more in this section. Notice it starts off by asking us to factor the function. So let's set our equation equal to 0 and see what our brains remember. X to the 4th minus 81 is equal to 0. Okay. We know how to factor this. I should start off by asking the question, is there any GCF? X to the 4th and 81, do they have anything in common? No. Okay. Think about forms. What form does this look like?
Oh, we can factor it.
Huh?
We can factor it.
Uh-huh.
It's the parabola. X squared, right?
I mean, are you talking about what the graph looks like?
Yeah, because it'll have x squared up front.
Well, but my high power right now is x to the 4th, yes? Or are you talking about?
Like we're factoring.
Okay, so I think you might be onto something. I'm not sure if you're there or not. What do we know about 81, guys? It's a perfect square, yes? Is x to the 4th a perfect square? Yeah, okay. Are these perfect cubes? No, 81 is not a perfect cube. Your calculator would give you a decimal. X to the 4th doesn't divide by 3. So if you go back to our polynomial identities on that pink paper, this is difference of squares. Which means difference of squares, it factors into 2 parentheses. What is the square root of x to the 4th?
X squared.
X squared. So the front of each parenthesis is an x squared. What is the square root of 81? 9. So the back of each parenthesis is a 9. How do you multiply to get a negative 81? Plus minus. Now, and let me state by, no, I did not want you to set this equal to 0. I mean, just solve it to begin with. We need to do the factoring today. Okay? If you try and solve this, you're going to miss out on some answers. Now, here's where you have to stop and ask yourself, am I done factoring? We had one in homework. Some of you didn't like it very much, and I don't blame you. They kind of threw it in tricky-like. But are we done factoring? No. Which one still factors? No. X squared minus 9, is that another difference of squares? Yeah, that's more the one you're used to. Now, do we have something called sum of squares? We have sum of cubes, but do we have something called sum of squares? We do not. Okay. So this one, x squared plus 9, because that's a plus sign there, x squared plus 9 is just going to carry down. It cannot be factored as much as you want to. The only way it can be factored is if there's a plus 6x in the middle. And we don't have that. Now, x squared minus 9. That does factor. What is the square root of x squared? X. So what's in the front of each parenthesis? X. What's the square root of 9? 3. So what's in the back of each parenthesis? A 3. How do we multiply it again? Negative 9? Positive and negative. So x plus 3, x minus 3. Okay. At this point, we are completely factored. So what am I going to tell you to do? Set each factor equal to 0. X squared plus 9 equals 0. x plus 3 equals 0, and x minus 3 equals 0. Two of those are pretty obvious and easy, yes? If I work my way back across, if it's x minus 3, what do we know? Add 3 and x equals 3. If it's x plus 3, what do we know? Subtract 3 and x equals negative 3. Okay, what about x squared plus 9? Officially, to solve that, what are we going to do? Subtract 9. So then you end up with x squared equals negative 9.
Can be square root both sides.
Okay, and then if it's x squared equals a number, you can take the square root of both sides. The square root of x squared is x. What's the square root of negative 9? Okay, the square root of 9 is 3. Because there's a negative out front, we're doing the square root of a negative number. That's an imaginary number, right? So square root of a negative makes it I. So square root of negative 9 is 3i. We're sitting in the equation situation. And when you take the square root in an equation situation, what do we need to put out front of it? Plus minus. So officially, my other set of zeros there are plus or minus 3i. Now, tell me, where are plus and minus 3i on a graph? Can we see those? No. Okay, what we graph on the x and y axis are all real numbers. We don't see any imaginary zeros. Those are truly zeros. There are such things as imaginary zeros. But in terms of our graph and what we're looking at here, we're only focused on the 3 and the negative 3. Okay? The plus or minus 3i are just the other zeros that we're not going to worry about right now. Okay? So now, as you start to think about this, what numbers go on this number line that we're going to be testing on? We're going to have a negative 3 and a positive 3. We're not going to put the imaginaries on there. They're not going to be necessary. So just negative 3 and positive 3. And then what form are we testing in? The factored form. So I would go for the farthest factored, you got it. Which means I would use this form. So I would use the x squared plus 9 times x plus 3 times x minus 3. Am I saying you can't use x to the fourth minus 81? Not at all. You can use that as well if you want. Okay? I'm just trying to go for which one's going to do without messing with my calculator. So, what number to the left of negative 3 is my brain thinking? Probably negative 4, yes? Now, think with me on this x squared plus 9. Negative 4 squared is going to be a positive, yes? Positive 16 if you want to go specific. What happens when you get a positive and you add 9 to it? You're still going to have a positive, yes? Let me give you a hint, guys. X squared plus 9, that one will always be positive. No matter what number you plug in, it's going to be positive. Because you square any number, you get a positive. You add 9, you just get a bigger positive. So it's more about these other two. X plus 3, so negative 4 plus 3 is going to be a negative. Negative 4 minus 3 is a negative. What's a positive times 2 negatives? A positive. So this graph is actually starting off positive. Okay. What about a number between negative 3 and 3? Say, I'm going to use 0. It's the only time today I get to use 0, but I'm going to use it. The 0 squared plus 9. As I mentioned, it's going to be positive. 0 plus 3, positive. 0 minus 3, negative. Two positives times a negative is a negative. And lastly, pick a number past 3, so we're using 4. We plug in 4. 4 squared plus 9, of course, is positive. 4 plus 3 is positive. And 4 minus 3 is positive. 3 positives multiplies to be a positive. Did we get a graph that's going to look a little different? We did. Okay, set it up with me. What do we know? Where does my graph have to cross the x-axis? At 3 and negative 3. There's where we're crossing the x-axis. Can you visualize what this graph looks like? It's going to be what? Positive, negative, positive. So we're going to start positive. We're going to go negative. And then we're going to go positive again. Does it look kind of like a parabola? Yeah, it's x to the 4th, so it's not exactly like a parabola. The base is a little wider and flatter, and then it goes up straighter, but it's a basic shape. Now, curiosity, just try and make the connections in your brain. Does my in behavior make sense? We had the highest power x to the 4th. If the highest power is even, what's my, it's either up, up, or down, down. It's a positive x to the 4th, which means it is up, up. Okay? You can definitely shorten this up and get quicker with this on your own. Okay? I know some of you will take some shortcuts and whatnot, but the idea is to be able to look at the factors and figure out how that affects the graph. That's what we've got to be able to do. I can stop here where first hour stopped, or I can keep going.
So,
It's also Friday, right? And I'll be honest, did I want to do new notes today? No, I didn't. I'm with you guys. I didn't really want to do new notes today, but here's the deal. I'm running out of days between now and Christmas to get everything in. Like, we need to be at the end of Unit 4, and I don't know if I have enough days to make it happen. So, but with that in mind, there's no point in getting past first and fifth hour. So, we'll stop there. Is lesson 3.5 available in Savas? It should be now. I don't know what order it's in. Are there a few you could possibly work on at some point? Yes. Is this possibly going to be a 3-day lesson? It is very possibly going to be a 3-day lesson because we still have a lot to do. Okay? I'll have to look and see if there's a way I want to or can shorten it up, but there's a lot here. And it's important stuff. So, we will pause for today and come back Monday.